how it should look like. So currently, I have created something that is interesting. So I have a remix. The remix, I have two contracts. One contract is a very simple name service. It basically have information that tells who owns a domain and who is the who are the basically the address that I want people to browse to, which I call pointers. And so this is a simple name service. And there's also a simple flag directory, which mimic the directory of flags with a simple operations like file. I want to read the files, so I call files. And there's write, there's a remove, and there's no ls because like I don't want to like put too much things on that. So I just has this basic three functions. Okay, so now I would like to compile the name service. Compile it. Now I have a set of testnet. So it's using 256. Actually, it is. I reuse the Heckle testnet. So I don't have time to apply for testnet ID first. So I just pick a random testnet ID and set up my testnet so that I can basically demonstrate basically end-to-end what that looks like. So I have fully control of the network. Okay, now because I already deployed it, so let me I just find the address. So let me find the address here. Is I have let's see, actually I can move it to another. Oops, it's oh, let me just search it. Search it online. Server. So oops. It's not here. Here it's got it. So this is a contract. So let me find it. So now it's here. And so, for example, I already claimed it. So let me put my names here. So QiZhou, which will returns what? Correctly. Please correct. Why not? Okay, let me just do something more differently. So now I need to find the hex of my. So this is my hex. So I'm able to first find the owners. String versions and by. Alright. Oh, sorry, already playing with. Yeah. So I need to find the owner. Why can I copy to translate? It's very weird. So I have to put here. So it sets like this will connect to this contract. Okay. So let me do so now it says it's working. Okay, this is a working one. So let me create a one for DappLearning. Okay. So let me compile this. So and let me find the name DappLearning. AEE learning is text. So first I need to claim it. So I claim this website is me. Okay. So I submit the transaction, claim it, and it's submitted to EtherScan, submitted to the testnet, and it should be included in the next block. Okay, now it's included in the block. Right. So then now I deploy this black directory. And then I will next will be set the pointer. Set pointers. So I need to find the full representation. Okay, it's already out. So now full is Dapp Learning. Plus I need to pad it so that it can be so that it can be 532. So now it says it's decorated. It's this with this address. Okay. So now I set a pointer. Set this is basically the name, Dapp Learning, and then I set the address. This is which I created. So now you see that this is pointing to the basic contract for us. So this means that like this, like we have a set of ENS kind of link service, and then it will directly find this contract to do something. Now let's do the rest of things. So the rest of thing we will do like says, let me write something, okay? So that's file name, okay? So then, let's write hello the text. Let's prepare this one. The file name is called hello the text. And next step is to create the content. So let's create a content called welcome to the Dapp Learning. Okay, text. Okay, this data I want to display on this. So let me put it here. This data, let me write it. Oh, it says, oh, there's a space here. I don't know why it includes space. Okay. So I'm going to submit it to the network. Okay, now it's done. So how we are able to read it? So right now we haven't created a parser here, but I create a server to handle this. It's kind of like inferior, but we can demonstrate it. So it's called testnet. Which is the entry point. Now we call Dapp Learning files hello. Oh, sorry. I need to put the W here. This is the here. See, now we are able to read this thing from blockchain. Any questions with this?
So the demo finished the storage text file and show on your browser.
Yes.
Yeah. So it basically finished the cloud computing and storage.
Cloud computing? I'm not sure. I'm not quite understand because like So this data is written in the blockchain that I put here, right? And then so basically when I type this, it will basically find the DappLearning this domain and find its address. And then it calls the smart contract regarding the file method with the file name that I want to display. And then it returns the data in the smart contract, which is called welcome to DappLearning. Right. So this is the same steps. Here I just shows this HTML data here.
Yeah, but the cost of storage huge file in contract, how can I resolve it?
Which storage file?
The cost of store and file huge files on contract, online contract.
Oh yeah, that's an interesting problem. So right now, actually, an interesting solution is that using a KV storage. Actually, you can using the code as a storage, which can save up to 1/3 of the gas using Ethereum current module compared to using the storage, and also maybe 10 times gas savings in terms of rate. So you can store up to 23K data on top of the blockchain, and using this library that I already created, and that is basically using the cold storage as a large key value store to store the data.
So the code storage is a way to storage file in code. I don't know.
Actually, I can talk about this idea next time. So
Okay.
basic idea is that when I create a contract, in Ethereum is only allows up to 24K size. And then when I create a contract, I will first create a contract that is really simple, that is able to self-destruct itself. So you can see this is kind of a contract that is very simple, just have an owner, it can self-destruct itself.
Okay.
And it will just create roughly 200 bytes data. But at the same time, I have a very interesting method that I can insert the rest 23K data in the rest of contract. So that as a whole, the contract can be huge, but it just do a little things. And then, but at the same time, I can read the rest of 23K using just 1/10 of the storage cost as using the standard AV in storage, that's kind of storage. To see this is some way that we are able to store arbitrary size data, especially for large object, and which much lower efficient gas cost. And we have further interesting improvement there, but I don't think this is the problem right now, because there are other very cool features that we already developed that can further solve this problem. That's why we are set up this testnet to demonstrate.
Yeah. Great.
Yeah, I have a question. So, from my understanding is that in your decentralized Web 3.0 model, the extension just translate the ETH address into the contract. I mean, the long tail contract address, and find that contract address in the node, and then get the content of the contract out and then load it in the cron, right? So, but that's the play stuff, right? So when we want to, make some kind of transaction, do we still need to sign? But if we need to sign, do we still need to, do the RPC from this kind of centralized node service provider. So I think it's just a kind of way to decentralize the display side. Is that a way to decentralize the interaction side as well? So
yeah, that's pretty. That's actually transaction side is much easier because once you have signed transaction, like read side is much difficult because there's a lot of things API you want to handle. But the right side, when you sign a transaction, basically what Ethereum you are connecting to a node that Ethereum, for example, mainnet, it's connected to your local browser, and the local browser just broadcasts your transaction to the P2P network directly. So it's much easier compared to if you just purely want to submit the transaction. But there's other complicated things for estimate gas, estimated, for example, whether you have nonce, all kinds of things. But still, you can do a simple Ethereum RPC node within your browser and offer the service to your MetaMask. And then at the same time, it just forward all the data to the network. So it's as long as we can do this, there's a lot of ways to solve the problem.
So what you mean is that the extension can just propaganda your transaction directly into the P2P network instead of putting the transaction into the MetaMask service and let the MetaMask, propaganda into the P2P network. Okay, yeah.
Okay. Actually, I can do a more fancy feature. So let me do a little bit more. So now we just create a new one. So just go back to my domain. Okay, this is my domain and convert it to hex. This is my hex. Okay, let me think. I want to what I'm going to do. I'm going to upload my webpage on the website. And so the webpage is, let me show you how the web page looks like. So this is the webpage of me. So this is some text, and there's my picture, which is linked to my photo.html. And then there's a so-called the website is hosted complete by the blockchain itself. Okay, so this is my HTML. So first, I will need to have this data. So let's open it. Let's just close this one. With definitely open. Edges. Keep the full pass. Come on. So I need to read it as binary. Sorry, this is wrong. F. Okay, now I have the data. So data content, and then I want to write to call index.html. Okay, now we have all the data we collect. So first, I want to look up the contract. So I go to here and go back to the remix. And first, I need to find where is my contract is. So let me find the pointer of the X. Where's my contract? So I think this is one. This is the one. So let me open it. Okay, now I have a contract that is points to my domain. Okay, so I want to write a file, which is the name, which is the index.hex. So I put here, and the data is here. So we can double check the data size. So which is 48A. So this far, like from far can put into the contract. So you can easily put it in the contract. Now we have all the data, transact. Okay, now we have the data. So let me tell what is my name dot not hello, but index.html. Whoa, nice. So, oh, that's one thing that I missed. My picture is not uploaded yet. So it's linked to, let's see. It's linked to body. There's a lot of stuff. So it's linked to testnet.io, my domain, files, my photo.jpg. Okay, it's not uploaded. So let me do something more. So first, I need to know my photo.jpg is here. Okay. And second is like I prepare one of my photo image. So let me display. This is my photo. Make a copy. And so now I place this part. And with it. Show it. So now this is the photo. So first I copy the name. This is the name. Second is this is the data. I still need to remove the space there. So now I submit it. Wait for the transaction to be processed. Okay, it's done. So now let's show them. Whoa, it's here. Oh no, it's oh, this is something. Oh yeah, it's still working because like it's I use my local HTML, it open, right? But now let's do this. See? So now it can successfully read all of this data, and the website is here, and then it can basically display all the content. And then I can further, for example, do other things, but like due to the limitation of today's presentation, I can demonstrate like several other interesting things that, for example, multi-link pages, all these things. So yeah, but I think this should illustrate the general idea how it looks like. So in terms of Uniswap, people just filter. Oh, actually, one thing I want to display is like, hey, I feel like this link is still too long. I don't like this. So okay, let me do something for you. So let me set a default file, and which the default file is linked to the index.html. So in HTML server, actually we do a lot of things like that, right? We set a default file when our user browse directory. So let me go back to find the index.html, the hex. So let's set that default. So 0x transact. Let's wait a few seconds. Oh, it's done. Oh, nice. So let me remove all this. I don't like them. Or maybe perhaps I can just open a new window to show it. Why not this takes so much time? Let's try to solve it. Oh, interesting. Why it takes so oops. That's my so my server says is already working. How about latency? Not working. The server. Interesting. The server says there's no file. There's no request. So one question regarding about the latency. Actually, right now, because we are running directly to the server that we wrote, so it's actually the latency is the same as in Fiora. There's no difference there. But later, if we want to improve it using decentralized lifetime browser extension, then we will see how the latency. But I would imagine like it should still works fine because like the network basically we are able to connect to multiple clients and then multiply to read the data. Looks like the DNS is down. But this one works. This one is not. Oh, interesting. These storage. Yeah, I think it's correct. Why is this? Wow, interesting. Probably I need to double check what's happening there. I think it works yesterday, but I'm not sure it's probably there's server says there's no request.
Okay, we can continue the left content.
Sorry?
Oh, and say we can try later. Let's continue the left content.
So basically, there are several technical solutions to address this. So first, we need to be able to run Lifeline in the browser. Then most likely, we are going to use P2P. That is also be able to run a super Lifeline, kind of a BFT or with people-based BFT. That should work. Also, we need a protocol to identify Web3 resources. So how it looks like and how we are able to translate the method to the URL to, for example, to Ethereum protocol. And then how we are able to render the web content. For example, right now, one solution is to use the code as the storage. And also, we may be able also to utilize decentralized storage. Last time I mentioned about using kind of deterministic sorting to store a large amount of data. So actually with that, we are able to access this static data of a large amount of data. Right now, we can store up to 24K. And we are doing some optimization that should be able to have access more than 500K with some trick there. But with more data, then definitely we need kind of different storage. And also we can create a protocol to, for example, to write a transaction. For example, when user posts some link URL, then it's able to generate a transaction in core EVM and also update this data. And further, there's a token committee that need to adjust to if there are too much garbage that are stored in the network. So I think we already talked about the product. So there are a lot of things that we can be done. So for example, we can do a lot of tools. Like for example, when Ethereum is created, one of the most important tools is Solidity. So we need a lot of things. Like for example, we need more advanced file system contract. more backend contract and be able to resolve URL, handle bytes and solidity. For example, the memory library I found in Ethereum foundation examples, there's a lot of bug. Actually, there's one bug. There's one bug there. So we need a solid bytes library so that we are able to, for example, adjust more dynamic the web page. And we may also need to have tools to able to sync those data to the website. For example, when I want to sync a simple website, most of the, for example, website or like NFT project. So an artist say, "Hi, I create a lot of NFTs. I want to not only just create an NFT, but also using my, for example, name, and then I send those pictures to the blockchain, and then I want some tools to be able to quickly sync all those data to the blockchain, so that I don't need to, for example, do just like remix, just done one by one. Then, for example, I can also sync the Gitbook or even NPM.js repo, or dependency that may be. And then we also can integrate some ENS, other name services. And so there are also a couple of interesting applications. We are able to, for example, using the name service that build on top of that, a native name service. We may be able to, for example, to find whether ENS can help or can do something different. Or there's an NFT market that we are able to really put the image on chain and sell it instead of like we just said, hey, this is link. You can find it in PFS or AR. So and usually you can even destroy this image like on chain because if they don't want it, it's kind of like when people destroy an artist's painting, right? An NFT market that is purely built on top of blockchain. Like OpenSea, that's still running on top server, or DeFi website can be deployed on top of that, personal website, social file, a lot of things can be done. And lastly, so right now we have a testnet that is running. If you are interested, you can pay me to need tokens to play. So we also would like to airdrop the many token for anybody who can write any prototypes, the library, website, the applications, and we plan to launch the mainnets in next month. So you will have the feature, for example, like BBFT, and also be able to support up to maybe 200K large objects on chain directly. And we are also going to to execute these tools together. So this is pretty much all I want to share today. So I'm happy to answer any questions.
Okay, thank you, Dr. Zhou. I will stop recording.